So today we are going to start the second part of module number 4. So that is hybrid electric vehicles. So last day we had done electric vehicles. We have finished it. So there are configurations, performance. Inside performance, there are three parts. One is traction motor, tractive effort, transmission. Finally, there was vehicle performance. And in tractive effort, in normal driving, we have seen some different 3-4 cases. That is when the vehicle is being driven through a city, then frequent start-stop was there. How it is affecting the efficiency and fuel economy. Whenever the vehicle is being driven through highway, then how was the gear position and fuel economy, all these things we had seen. And finally, there was a brief discussion about energy consumption in electric vehicle, and we found that not every time we are supposed to drive the vehicle with maximum speed to get maximum efficiency. Rather, what we found was, if we are driving the vehicle in around 30-35% of its maximum speed, that time we are going to get efficiency almost as high as 90%. So all these things were discussed in under electric vehicles. So that was the first part of module 4, and that was over yesterday or last week. Today we are going to start with hybrid electric vehicles, and there are mainly 4 topics. Concept of hybrid electric drivetrains. Drivetrain means whenever the main energy that is being generated and it is propagated and it is going till the wheels, all the 4 wheels, and it is driving it. So starting from the generation up to the usage. So the whole process is called as a drivetrain. Now, what is the concept of drivetrain, electric drivetrain? So that we will see here today. And whenever it is hybrid, then there are 2 things. One may be the IC engine, one may be the energy produced by the gasoline, and second one is the energy produced by the electric. So together we are mixing, and when gasoline based drive should be working, when the electric drive should be working, all those concepts we have to understand from this. So concept of hybrid electric drivetrain is going to be today's topic. And later today, I will do another lecture because we had missed something on 8th of May. So that lecture will be compensated today. I will give you the timing. Mostly it will be around after 5. I'll record that. And architecture of HEV drivetrain and series hybrid electric drivetrain. So these 2 topics will be covered in that lecture number 27, which will be recorded today later stage. So if you want, you can join that. And finally, there will be another topic that will be done on Friday. That will be the parallel hybrid electric drivetrains. So by this Friday, this 4th module will be over. And what I've decided is there will be 2 OBS. The first OBS should be on module number 1 and 2, and the second OBA will be on module number 3 and 4. So if I finish this topic on Friday, mostly by Friday night or Saturday morning, the 2 OBA questions will be given to you. And on Saturday, we will start with module number 5. Okay, so this is the plan. Let us see what is the first topic, that is the hybrid electric vehicle, concept of hybrid electric drivetrains. So there are total 16 slides. What we are finding is in hybrid electric vehicle, what is the basics of it? It is said that the conventional IC engine based vehicle provide very good performance and a long operating range by utilizing the high energy density advantage of petroleum fuel. So this is the main advantage of petroleum fuel based vehicle, that is energy density is very high. However, conventional IC engine based vehicle have the disadvantage, that is fuel economy is poor and environmental pollution is one of the byproduct of this IC engine based vehicle. So though it is having high energy density, that means we can just put some petroleum in the tank and we can go for longer distance, but what we are finding is poor fuel economy. That means for 1 unit of energy, 1 unit of fuel energy, how much distance we can cover, that thing is not very good. Okay, and environmental pollution is always there, that means there are exhaust gas and all these things. So this first paragraph actually summarizes all the goods and bads of IC engine based vehicle. Main reasons for their poor fuel economy is based on there are 3 points actually. Number 1, the mismatch of engine fuel efficiency and operation requirements. Okay, so the matching between requirements and engine characteristics, they are not same. Second thing, the dissipation of vehicle kinetic energy during braking, especially in city driving. So too much of start stop kind of thing is done during the city driving. So actually that wastes a lot of energy in the IC engine based vehicle. And the last one reason because for poor fuel economy of IC engine is low efficiency of hydraulic transmission in present cars in start and go driving pattern. So we are finding that the steering that we are using, this is actually power steering, and it can be a hydraulic kind of a power steering, or the brake that we are using, it's a kind of a hydraulic brake. So there are a lot of hydraulic power transmission in the vehicles, and in the hydraulic power transmission, if it is stop go start and stop kind of a thing that happens in the city, so a lot of power is wasted in the hydraulic power transmission in the city that we are finding. So these are the three main reasons why fuel economy for IC engine based vehicles are poor in the city driving. Now, what is the option? Option is we have to add another auxiliary kind of a thing with the IC engine based vehicle. IC engine based vehicle will be there. With that, another thing will be added, and together they will make a hybrid system. So battery powered electric vehicles or EV on the other hand possesses some advantages over conventional IC engine based vehicle, such as high energy efficiency and zero environmental pollution, because they run only on electric energy, so pollution is not there and their energy efficiency is very high. However, the performance, especially the operation range for the battery, are not very poor. So is far less competitive than IC engine based vehicle. Efficiency is very poor. So due to the much lower energy density of the batteries than of gasoline. So how much energy is packed in the fuel? Okay, so that is much more in case of gasoline. That is less in case of battery. That is electric thing. But hybrid electric vehicles are having some positive points. What are they? It uses two power sources, a primary power source and a secondary power source. So they have the advantage of both IC engine vehicles and EVs to overcome the disadvantages. So first, it is explained why IC engine based vehicle and why not IC engine based vehicle. So these are the first 2 points. Third point is what are the advantages and disadvantages of EV. Okay, and then we are mixing IC engine and EV and producing a hybrid electric vehicles. Okay, which uses two power sources. So first primary power source can be the IC engine based vehicle. Secondary power source can be the electric vehicle. So here the H hybrid electric vehicle is having the advantage of both IC engine based vehicle and EVs to overcome their disadvantages. So in this session, the basic concepts of operating principles of HEV powertrains are discussed. So there are various powertrains in case of hybrid electric vehicles that we will discuss in this session. So concept of hybrid electric drivetrains. What is meant by drivetrain? So powertrain or drivetrain is defined as the combination of the energy source and the energy converter to power switch, such as the gasoline for diesel engine system, and heat engine system, hydrogen fuel cell, electric motor, chemical battery, electric motor, and so on. That means all the power sources, they are added together, so that is actually creating the powertrain. A vehicle that has two or more powertrains, so there is a formal definition of hybrid vehicles. A vehicle that has two or more powertrains is called as a hybrid vehicle. Broadly speaking, a vehicle may have more than one powertrain. So some vehicles, most of the hybrid vehicles we are finding it is gasoline as well as electric together. Basically, any vehicle powertrain is required. So there are requirements of powertrain. Number one, develop sufficient power to meet the demands of vehicle performance. Now, vehicle performance can be different. On highway, its demands are different. On above upgoing slope, its requirement is different. In the city, its requirement is different. So whenever I'm saying powertrain, it should be able to sufficiently supply energy for all the conditions. So develop sufficient power to meet the demands of vehicle performance, carry sufficient energy on board to support the vehicle while driving a sufficient range. That means for longer range. Demonstrate high efficiency and emit few environmental pollution. That means it should be able to produce maximum energy with minimum amount of pollution. Now, what is a drivetrain and details is given in the last paragraph, very important paragraph. The drivetrain of a vehicle is defined as the aggregation of all the powertrains. So that there can be more than one powertrain. There can be IC engine powertrain, electric vehicle powertrain. So drivetrain is the accumulation of that. A hybrid vehicle with an electric powertrain is called as HEV. That is hybrid electrical powertrain. A hybrid vehicle drivetrain usually consists of not more than two powertrains. So HEV actually is consisting maximum two powertrains. More than two powertrains makes the drivetrain very complicated. So optimum is two. So two powertrains are very good in case of one drivetrain. To recapture the braking energy that is dissipated in the form of heat in conventional IC engine vehicles, a hybrid drivetrain usually has a powertrain that allows energy to flow bidirectionally. So what is the main advantage of hybrid electric vehicle is it actually do two things. First one is it supplies the energy for vehicle driving. Second one is during the regenerative braking. So there's a very important point. During the regenerative braking, it takes back some of the energy and it sends it back to the charging the battery. So that is a very important thing. So to recapture the braking energy, so this is actually happening in HEV. To recapture the braking energy that is dissipated in the form of heat in conventional IC engine vehicles, a hybrid drivetrain usually has a powertrain that allows energy to flow bidirectionally. That means it is going from the source to the load, as well as during regenerative braking it is flowing from load to the source. So bidirectional energy transmission is possible by using some kind of H hybrid electric drivetrain. Now here, this is the main diagram you have to remember. So this question can be asked for 5 to 6 marks. That is, what is the conceptual illustration of hybrid electric drivetrain? So you are finding here, this is the energy source 1, okay, and this is the energy converter, and then this is the load. So first you can say this is the IC engine based thing. So this is the called as powertrain. So many powertrains together, they are actually making the drivetrain. So this is one very important thing. This is a powertrain. Okay, so IC engine based. Then energy converter. So from energy converter to energy converter to energy source. So this can be the battery, the second thing. So here the first thing is IC engine based thing. It is converting energy, and this gasoline based energy can be converted to battery electricity, and it can charge the battery. So there are actually two flows. One is a power flow while propelling. That means power flow while driving the car. That is this. So you can see that this is the first thing, this is the second thing, and load. Load is nothing but the vehicle, wheels and all those things. This is loading. So this is the forward train. This is the forward train, and this is the mechanical part mainly. So this is a power flow. So here it is electrical, and this is driving the load. So whenever there are solid lines, it is actually for driving the load. And whenever power flow while charging the powertrain too. So this is that battery, and a lot of energy can come from different sources. So it can come from principal energy source to charge the battery, or it can come from the load through regenerative braking to charge the battery. So these are there are main three components you have to understand. First is energy source 1, that is generally the IC engine or so. Second source, this is the battery, and third source, which is the load. So there are different kinds of powertrains, and all these powertrains together, they are actually producing the drivetrain. So one powertrain can be energy source to load, another powertrain can be energy source to load, another powertrain can be load to energy, that is actually regenerative braking, another can be energy source to energy to, that is actually charging the battery, and many more. So there are total 8 or 9 cases which are explained in this lecture. Please concentrate. The figure shows the concept of a hybrid drivetrain and the possible different power flow routes or routes. A hybrid drivetrain can supply its power to the load by a selective powertrain. Okay, so this is the first powertrain, then this is the second power flow while propelling, and then here. Okay, together it can go and do the load driving. Second source also can give the power in the positive direction. So energy source, converter, and then load, and it is driving. Likewise, so there are many available patterns of operating two powertrains to meet the load requirement. What are they? We will see. So there are 9 powertrains we have explained here. Number 1, powertrain 1 alone delivers its power to the load. So powertrain 1, and it is delivering the load power. Second to powertrain 2 alone delivers its power to the load. So energy source 2 alone can drive the load. Third thing, both powertrain 1 and powertrain 2 deliver their power to the load simultaneously. So energy source 1 is giving power, energy source 2 is giving power, and together they are driving the load. That means IC engine and electricity both are maybe together they are driving the load, or maybe this is battery 1, battery 2. It's possible. Powertrain 2 obtains power from the load. This is regenerative braking. So see this arrow. This arrow is backward. So this is actually power flow while charging the powertrain. So it is coming back, and this is actually the regenerative braking. So this dashed line is one powertrain from load to converter, energy converter to the energy source. So energy converter can be inverter and those things, inverter or chopper, all those things. or rectifier can be. Okay, likewise, so it comes to the energy source 2. So this fourth is very important because this is regenerative braking. Fifth thing, powertrain 2 obtain power from powertrain 1. So this is the loop I told you, that energy source first one is actually obtaining the power from energy source 2 obtaining the power from energy source 1. Then powertrain 2 obtain power from powertrain 1 and the load simultaneously. That means this energy source 1 as well as the load together are charging the energy source 2, that is battery. Powertrain 1 delivers power to the load and to powertrain 2 simultaneously. So there's a very big pressure on the powertrain 1, that is it is giving the power to the load, and at the same time it is actually charging the battery itself. Okay, so this is a very big pressure on powertrain 1, that is powertrain 1 delivers the power to the load and to the powertrain 2 simultaneously. Okay, that is the case. Next is powertrain 1 delivers its power to powertrain 2 and powertrain 2 delivers its power to the load. So this energy source is charging the energy source 2. This is one case, and this energy source 2 is giving the power to the load. So this is another case. So in one case we found that energy source 1 is delivering the power to the load as well as energy source 1 is charging the battery. That is one case. Another case, energy source 1 is charging the battery and this battery is actually giving the power to the load. So this is case number 8, please remember. And the last case, powertrain 1 delivers its power to the load. That means this solid links. So powertrain 1 delivers its power to the load and load delivers its power to the powertrain 2. Okay, so these are all 9 combinations which are possible, and together whenever you are saying powertrain, so this is a powertrain, that is dash lines, okay, power flow, such many powertrains together is producing a drivetrain. So what all 9 different drivetrains are possible, it is given here. Now in detail analysis of each of this powertrains we will see. So what are the patterns? So all these 9 patterns are explained. Let us have detailed discussion of these 9 patterns. So in gasoline or diesel IC engine, which is called as a powertrain 1 or which is the energy source 1, and battery electric motor, which is the powertrain 2. So it is given very clearly, that is powertrain 1 is IC engine, gasoline, and powertrain 2 is the battery electric motor. So pattern 1. So together, what is the pattern 1? So powertrain 1 alone delivers the power to the load. Okay, in this case, this energy source 2 is not taken into account. This powertrain 1 is delivering all its power to the load. Okay, so it is the engine propelling mode. So it is only propelling. So there is no regenerative braking in this case. Powertrain 1 is directly giving all the required energy to the load. So this may be used when the batteries are almost completely depleted. So battery 2, even if this energy source 2 wants, but it cannot supply anything because this energy source 2 is kind of totally exhausted or depleted. So and the engine has no remaining power to charge the battery. So engine cannot charge the battery. This battery is totally depleted. So what engine can only do is engine can only do the main work of driving the load. So what are the conditions? Condition is engine can only supply the energy to the load. Load cannot charge the energy source to battery. Engine doesn't have extra energy to charge the battery. So these conditions we have to understand, in which case pattern 1 is used. So pattern 1 is used when the battery is almost depleted, exhausted. Engine doesn't have any energy to charge the energy source to. Engine does only one thing, that is it sends the power to the load. And this load also cannot charge the energy source too because regenerative braking is not happening. Okay, so these are 3-4 cases. If you put together, that is actually the condition for pattern 1. Okay, so this may be used when batteries are almost completely depleted. First case, engine has no remaining power to charge the battery. Second, when the batteries have been fully charged and the engine is able to supply sufficient power to meet the vehicle power demands. So this is another case. That is, battery is fully charged. So this engine does not have to give any power to the battery. So engine in that case can only do one thing, that is it can only run the load. So when the battery is totally exhausted and engine cannot have any extra energy, so engine cannot charge it. This is one case. Battery is fully charged. In that case, battery can give some energy to the load, but what this energy source 1 is saying, I am capable of supplying the load. So I don't need any help from the battery. So all these cases you please go through. So these cases are sometimes feeling contradictory, but very practically you have to think. And all these things are actually controlled by the ECU. Okay, so what is the state of battery, what is the state of engine, and who can supply the power, whether the supplied power can be sufficient or not, all these things are continuously, state of charge is monitored, engine performance is monitored, load requirement is monitored, and depending on that the ECU takes the decision who is going to send the power to the load. So this may be used when, so this pattern 1, that is only the energy source 1 is supplying the power to the load. This can happen only when the battery is either totally depleted or battery is totally charged. In both the cases, in the first case battery is depleted and source 1 doesn't have any energy to charge battery 2, so what the engine will do, it will only supply to the load. Okay, or maybe in the second case, that is battery is fully charged, okay, and the engine is able to supply sufficient power to the load, then also this first energy source does not need to charge the battery. So this is the first case, which is only big, remaining cases are small. So pattern 2, the pure electric propelling mode. So what is the pattern 2? In the previous slide, if you see, powertrain 2 alone delivers its power to the load. So this is a pure electric propelling mode. That means this energy source 2, which is nothing but battery, through the converter. So this is DC. DC is again converted to AC by in case of an inverter, and that is actually driving the load. So there may be a motor in between. So motor is driven totally by the converted AC. So initially it was DC, converted AC, or chopper, PWM, all those things we have seen, and it is actually driving the load. So pattern 2 is a pure electric propelling mode in which the engine is shut off. Okay, so this energy source 1 is not doing any work. This pattern may be used for situations where the engine cannot operate effectively. There may be cases that engine is no need to come into picture. So in this case, very low speed or in areas where emissions are strictly prohibited. So there may be some cases where car emission is strictly prohibited, or you may be fined because of car emission, or maybe the exhaust is not working fine. Okay, in that case you might get visible that your that PUC and all these things are not done, and you can find that car is exhausting huge amount of black smoke. In that case, what you do is shut down the energy source 1, that means IC engine, you just shut down, you turn on the electric vehicle mode and drive a clean drivetrain, use a clean drivetrain, and use the electric kind of a propelling method. So in this case, the pattern 2, that is energy source 2 is driving the load. So in this case also regenerative braking is not possible. In that case, charging of the battery by using powertrain 1 is also not possible. So it is only a forward directional flow. So from energy source 2, energy converter 2 to the load it is going. Third case is a hybrid traction mode and may be used when high power is needed. So this load is asking for too much power. Half of the some of the power is going from energy source 1, that is the IC engine, and some of the power is going from the energy source 2, which is a electrical thing. So such as during sharp acceleration or steep hill climbing. So only during the climbing of the hill we need both the things to be turned on. Okay, and when the hill is climbed, we are at the top. Again, the car becomes flatter kind of a thing. So initially the car is like this, car is going up. So in that case, both the energy source 1 and 2 are to be on. And when it goes up like this, and then energy source 2 is switched off and only energy source 1 keeps on going on. So such as during sharp acceleration or steep hill climbing, both the tractive effort from source 1 and source 2, they are made on together. Fourth case, the regenerative braking. So this is a very important thing because we have studied it, and regenerative braking is happening only with the energy source 2. So in this, the kinetic or potential energy of the vehicle is recovered through the electric motor functioning as a generator. So the recovery energy is then stored in the battery and reused later. So what was the case of regenerative braking? When the vehicle is going down, that's a steep slope. So even if we are not giving much of the energy, so a lot of people do what? They in the bike I have seen that they switch off the vehicle. Okay, in that case, so by using that key they switch off the vehicle, then also vehicle is going down, and then also the vehicle is rotating, and in that case it can charge the battery of the vehicle. So that is possible. So that is actually regenerative braking, mainly happening when the car is going towards a slope below. Fifth, here the engine charges the batteries. So this engine is charging the battery, and vehicle is standstill, coasting, or descending on a slight grade in which no power goes into the comes from the load. So what is the fifth case? Fifth case is powertrain 2 obtain power from powertrain 1. Okay, so this powertrain 2 is obtaining the power from powertrain 1 in this case. Okay, Okay, so in this case also, if the vehicle is standstill, coasting or descending on a slight grade, in this case, this powertrain 1 is actually charging the powertrain 2. For pattern 6, this is the mode in which both regenerative braking and the IC engine charge the battery simultaneously. So both the things, that is energy source 1 as well as load, both are actually charging the battery. So huge amount of charging energy recovery is happening in pattern number 6. Pattern number 7 is the mode in which the engine propels the vehicle and charges the batteries. So in this case, engine is propelling the vehicle. That means this energy source is propelling the vehicle and charging the battery. Both are happening simultaneously. Pattern 8 is the mode in which the engine is charging the battery and battery supply the power to the load. So all these things are already explained in that single slide. Okay, so in pattern 8, engine is actually sending the energy to the battery and battery is actually sending the power to the load. So in this case, requirement of huge power is not there at load. So whatever energy source 2, which is a kind of a mild energy storage, a little bit milder compared to the energy source 1. So energy source 2 in this case is sending the power to the load. Not huge amount of power is required, and energy source 1 is actually charging the battery. In the last case, pattern 9 is the mode in which the power flows into the batteries from the heat engine through the vehicle mass. Okay, so this is also another storage kind of a thing. The typical configuration of this mode is that the two powertrains are separately mounted on the front and rear axles of the vehicle. So this is a kind of a special case, case number 9, in which case there is a regeneration kind of a thing happening and the battery is getting charged. So these are the 9 cases you might have to explain, and this diagram is very much required while you are explaining all these drivetrains. So these are 9 concepts which have to explain who is supplying whom at which requirement and what is the case in which some specific drivetrain is being used. It is not difficult, but remembering all those 9 things at the same time is difficult. But if you're doing it with this diagram in front of you, then it becomes easy. So many different types of powertrains, many different type of drivetrains you have to remember. Now, hybrid electric drivetrain concept. So this is actually the HEV drivetrain. Independent operation modes in a hybrid vehicle create much more flexibility over a single powertrain vehicle. What is a single powertrain vehicle? Either it's an electric vehicle, so only power is coming from the electricity battery motor, and if it's a only single gasoline-based IC engine vehicle, in that case, power is coming only from the IC engine. But in that case, the problems is I told you that IC engine is having its negatives, that it creates a lot of pollution and all those things, and its power efficiency is high, but fuel economy might get hampered in some cases. Okay, so in those cases, electric vehicles, so some auxiliary, okay, some auxiliary, it's somewhat like you are having a salary and you are having a steady salary of maybe 1 lakh rupees per month, and there is some side income of 20,000 rupees per month that is happening. So that 20,000 rupees may not be used every time, but yes, if there comes some very important kind of a sudden kind of requirement, at that time that 20,000 can be called as an ancillary service or auxiliary service that can give you support. So whenever there is some peak demand or something, peak, P-E-A-K, peak demand, at that time that secondary source comes into picture. So that's why hybrid is always better than single source supply. So very important thing, they have said the abundant operation modes in hybrid vehicle create much more flexibility over a single powertrain vehicle. So it offers flexibility of driving, it offers flexibility of your different modes are there. So 8 or 9 modes we have seen. Regenerative braking is possible if there is a combined kind of a drivetrain mode. All these things are possible. So with proper configuration and control, applying a specific mode for a special operating condition can potentially optimize the vehicle performance. A very important line, that if we want to optimize the vehicle performance, the meaning of optimization is minimum amount of resources I am giving and I am able to cover maximum amount of distance. So that is meant by optimization or fuel optimization. So we have to optimize the overall performance, efficiency and emission. So emission is a very important thing, maybe not in our India, but abroad emission is a very important thing. So if your car is showing much more emission, then possible that your car might be banned, okay, from the road. So that is also possible. So that's why in India we might not feel that this HEV or double drivetrain is very much important, or combined drivetrain is very much important. But yes, abroad, where this emission is a very big thing, there this combined or hybrid electric drivetrain is very much required. So, however, in a practical design, deciding which mode should be implemented depends on many factors, such as physical configuration of the drivetrain, powertrain efficiency, load characteristic, and so on. So it is said that whenever it is that start stop kind of a thing, in that case fuel economy gets hampered for IC engine based vehicle. So in that case, whenever it is that start stop kind of a thing, you are inside the city, at that time drive the vehicle by using electric. And whenever you come out of the city, you are on the highway or so, there you use IC engine based drivetrain. So that's why HEV is always required. So operating each powertrain in its optimal efficiency region is essential for the overall efficiency of the vehicle. It is obviously there because each drivetrain, if you are able to optimize, then you are optimizing the overall efficiency of the combined powertrain. So an IC engine generally has the highest efficiency operating region with a wide throttle opening, obviously on the highway. So wide throttle opening means a huge amount of fuel is going inside, huge amount of air is going inside, the vehicle is running with full throttle, full acceleration, then only IC engine is having its highest efficiency. But whenever electric vehicle is there, it is giving better efficiency inside city where start stop things are there. So whenever start stop things are there inside city, very low gear operations, that is you are always on the first gear, second gear inside the city, there use electric vehicle. On the highway full throttle, you use IC engine. So that is actually the meaning of this. Operating away from the region, away means whichever is that sweet spot. I told you last day, we have seen that driving a vehicle at around 30 to 50 kilometer per hour gives us highest energy efficiency. So if you are driving away from that, that means either you are driving your car with 10-15 kilometer per hour, or you are driving your car with 100-150 kilometer per hour. So you are going away from the efficient driving. Maybe you are reaching the destination fast, but the life or the optimized driving is not happening. That means you are not able to use the fuel in a best possible way. That means for unit amount of fuel you can go to the maximum distance. That is actually maximum efficiency. That is not happening. Maybe you are covering the distance faster, maybe you are reaching the destination fast, but the fuel economy is not maximum or not optimal. So operating away from this region, away from the sweet spot, away from the highest efficiency region is called as operating away. So on the other hand, the efficiency drops in an electric motor if the electric motor is not as harmful when compared to IC engine that operates away from its optimal region. So I'll read it again. On the other hand, the efficiency drop in an electric motor is not as harmful when compared to an IC engine that operates away from its optimal region. So what it does is it's actually comparing the efficiency reduction in electric motor based system, that is electric vehicle, and IC engine based system. So what the comparison has shown is that in electric vehicle, the harmfulness or the decrease in the efficiency is not very effective or not very considerable compared to the IC engine based vehicle. That means IC engine based vehicle, if you are not driving at that sweet spot, if you are driving too much away from the highest efficiency region, then reduction in efficiency is too much. Whereas in case of electric vehicle, if you are driving away from that specific range, that is sweet spot, then also we are going to get less efficiency, but that reduction is not too much, not severe. So we are comparing both the losses. Okay, so in EV as well as in IC engine based vehicle, both cases, if we are away from the sweet spot, in both cases we are reducing or we are losing some of the efficiency. But in which case loss is more, that is actually compared here. And what they're saying is in IC engine based engine, the loss is more if we are not driving in the optimal speed region. That is a comparison. So very important point. If we someday compare the electric vehicle and IC engine based vehicle, then one point can be written here, that in both cases, if we are not in the optimal region, so in both cases we get some kind of loss, but loss in case of electric vehicle is less compared to loss in case of IC engine based vehicle. Very important thing. So decomposition of load power into steady and dynamic components. So what they're finding is, so this is the load power. You're finding that load power is varying. Okay, and this varying load power is actually addition of one average power, that is this dark line, and another dynamic power. So what you are finding is the load power of a vehicle varies randomly in real operation due to the frequent acceleration, deceleration, climbing up, going down as shown in the figure. So here the load power requirement is high, here the load power requirement is low, and all these things are happening. So the load power is composed of two components. One is the steady average power, which is a constant value like this, and another is the dynamic power, which is a zero average. So you can say that if you just see this part, okay, so just draw a straight line, just draw a straight line. Okay, so this is the average power. So in this case average power requirement is less, in this case the power requirement is less than average, but in this case power requirement is more than average. So one energy source will produce this average power. This is what this diagram is meaning, that one energy source will produce that average power, and the other energy source will produce the dynamic increment and decrement. And if you add these two, so you just see this addition and this small addition, so this height and this height together is equal to this height. This you have to understand. So this is undulations, or this is ups and downs, ups and downs. This is actually produced by one of the two energy sources, and this average power is produced by one of the two energy sources, and this black line is actually the power at the load, and that is nothing but addition of this transient power or this dynamic power and the average power. So you see this part, this height, and you see this height together, it is producing this one. So the load power of a vehicle varies randomly in real operation due to the frequent acceleration, deceleration, climbing up and down as shown in figure. The load power is composed of two components. One is steady average power, that is this one, which has a constant value, and the dynamic power, which has a zero average. So this thing is a zero average thing. In designing the control strategy of a vehicle, one powertrain that favors the steady state operation, such as the IC engine or fuel cells. What we are finding is the IC engine or fuel cell based vehicle, they are good in giving a constant average power. So I told you that this is your monthly salary. This is your monthly salary of 1 lakh, and this is your extra income. So the extra income, sometime maybe this is from the share market. So depending on the share market, sometime you are earning 40,000 per month, but sometime you are earning 10,000 per month. Okay, so net salary is this. Okay, this is your monthly salary work. This is the average. This is the main chunk. Okay, and this is actually a kind of a performance based income, or this is not a very steady income. But sometime if you are making a good income, that will get added to this steady, and you are getting a very high peak sometime. So in designing the control strategy of a hybrid vehicle, one powertrain that has favors the steady state operation, such as the IC engine or fuel cell, may be used to supply the average power. So one thing is supplying the average power for continuous driving. Another thing, that is the electric vehicle, is supplying the peak power. Okay, so electric drive, there is a powertrain 2, is not for constant driving, or this is not for average power. This is for the peak power, so extra certain time. So it's hill climbing, so average plus powertrain 2 power. So here this may be the region of hill climbing with respect to time. So in this case, huge amount of energy will be fetched from the from the battery. Okay, and when you are going down slope and all these things, at that time power is not required from the ancillary. Okay, very less amount of power is required from the ancillary. So this is actually the hybrid characteristic, which is given at the top, and this is the best slide to understand what is hybrid electrical vehicle characteristic. So this is the overall power requirement, which is given by one average power, and another is the depending on time. So this is a dynamic power. So together the main power requirement will be fulfilled. Now, on the other hand, another powertrain such as an electric motor may be used to supply the dynamic power. So what was the last line? In designing the control strategy of hybrid vehicle, one powertrain that favors steady state operation like IC engine or fuel cell may be used to supply the average power. So this one. On the other hand, another powertrain such as an electric motor may be used to supply the dynamic power. So below is the dynamic power and top is the average power. Total energy output from the dynamic powertrain will be zero in an entire driving cycle. So you can see that this line, okay, the area below this line and area above this line, if you find their area, okay, that means this area which are above the line, okay, if you add this area and the areas below the line, if you just add them, so this positive and this negative cancels each other. So that is called as net average power is zero from this secondary or from this electric power source. So net average of the dynamic powertrain will be zero on an entire driving. So sometime the battery will be giving us energy, that is a secondary source. Sometime it will be giving energy, and sometime it will get back the energy from the load, that is the regenerative braking. So we can say that here extra energy is given by the battery, here extra energy is given by the battery, here also extra energy or peak energy is given by the battery. But these are the cases where the battery is receiving the regenerative braking power from the load. So whatever it is giving in this, all this extra times, this thing is being fulfilled or refilled by the regenerative braking. So overall energy given by the energy source 2 is net equal to zero. So that is a very important thing. Total energy output from the dynamic powertrain will be zero in the entire driving cycle. So very important thing. This implies that the energy source of the dynamic powertrain does not lose its energy capacity at the end of the driving cycles. It functions only as a power damper. That means whenever too much thing is required, it is giving, and whenever the car is going down, it is getting charged up. So give when required and charged when not required. Okay, so in good times it will be saving power, in bad times it will be giving out power. So it's like a damper. It is actually damper is kind of a capacitor, you can say. So it's a damper which is absorbing shocks. Okay, so whenever the big shock is there, it is giving. Whenever the shock is not there, it is absorbing. That means net effect on this primary energy source, it is absorbing actually any shock which is coming on this primary energy source. So very important line, that is that this implies that the energy source of the dynamic powertrain does not lose its energy capacity at the end of the driving cycle. Why? Because the total energy output from the dynamic powertrain will be zero in the entire driving region. Okay, so it functions only as a power damper. So I'll give you another example, that your salary is 1 lakh and you are keeping a 50,000 rupees as a safeguard. Okay, so that is kind of your piggy bank. So some month you might require 1,25,000. So 25,000 you get from there and you spend it. And next month, suppose whatever salary 1 lakh you are having, you do not require that whole 1 lakh amount. So maybe you are saving some 20,000. So that 20,000 again you give back to that piggy bank. So previously it was 50,000, you took out 25,000, so that piggy bank became 25,000. Now next month your expenditure is less, so you give that 20,000 back to the piggy bank. So it again becomes 45,000. So likewise, you are trying to keep that piggy bank always constant at 50,000 only. So this is actually like a cushion that is happening to you. Same thing is being done by the secondary source. So these two slides are very simple slides, but these two slides, whatever is written in the left side, you understand, and that is actually explaining what is the need of the secondary source and why EHB. What is that word H, hybrid? That hybrid word is actually explained in this two slides with respect to these two graphs very importantly. So please go through that. Now next is decomposition of load power into steady and dynamic components. So this is the last slide. What is meant by decomposition of load power into steady and dynamic components? So in hybrid vehicles, steady power may be provided by an IC engine, a stalling engine, a fuel cell, and so on. Okay. The IC engine or the fuel cell can be much smaller. So they are the energy source, but they can be much smaller than a single power train design, because the dynamic power is taken by the dynamic power source, and the engine can operate steadily in its most efficient region. That means if there are sudden glitches, if there are sudden spikes and all these things, that is actually taken care by the secondary source. So it actually reducing the main burden on the primary source. So very important, like this second line is, the IC engine or the fuel cell can be much smaller, because this has continuously, this will be generating a constant power. Okay, if there comes any shock or something, sudden surge or something, sudden requirement, this IC engine cannot do anything, because in that case it will directly show it to the secondary source, that whatever is the extra power required, you take it from that secondary source. So the IC engine or the fuel cell can be much smaller than that in the single power train design, because the dynamic power is taken from the secondary dynamic power source, and then the engine can operate steadily in its most effective region. So I told you that the most effective region is very important for any car. Let it be the battery source, or let it be the IC engine based source. And we have found out that IC engine based source, if it is not in the sweet spot, if it is not in that optimal region, then its performance deteriorates too much. So by doing this hybrid, what we are doing is, whatever happens, so this second line is very important. Whatever happens, the engine can operate steadily in its most efficient region. So whatever happens, the engine will always be operating in that 30 to 35, 40 kilometer per hour range, and it will be always be giving the maximum efficiency. Apart from that, if there is sudden requirement or spike or surge, that will be supplied by the secondary source. So this is the main fundamental of a hybrid powertrain. That is one source, that is in the previous slide what we called as average power or main source, that will always be in the its best or optimum efficiency region. That is the first thing. And whatever is the peak requirement above that average power, that will be supplied by the extra or ancillary or auxiliary supply. So the IC engine or the fuel cell can be much smaller, so not necessary to make its size big. Okay, so they can be much smaller and they will be giving the continuous flow of energy. So that is your main salary. And whatever is the spike, whenever there is a big requirement, that will be supplied by your piggy bank, whichever is there. So power, more pressure is not coming on your regular salary, because you know that there is a 50,000 you have kept stored. So if there is suddenly there is a requirement, you can always take it from the piggy bank and again you can give it back to make its intact, make its quantity always as 50,000. So main important thing, the IC engine or the fuel cell can be much smaller in size because it's the first primary power source, because the dynamic power is taken care of by the dynamic power source. So secondary power, electric storage, battery is the dynamic power store. And then the engine can operate steadily in its most efficient region. So I will underline this part and I will post it. Last line, the dynamic power may be provided by an electric motor powered by batteries, ultracapacitor, flywheel, mechanical batteries, and their combinations. So in the third chapter, we have studied different types of power sources. And now in the fourth chapter, we are coming to know what is the significance of those power sources. So IC engines and all these things we have studied long back, but they are main power source. But whatever batteries, ultracapacitor, flywheel, all those things we have studied in the third chapter, they are actually the auxiliary power sources. So together, IC engine and battery, IC engine, ultracapacitor, IC engine, flywheel is also called as mechanical battery. Okay, together they are producing the hybrid electrical vehicle. So next